Hello again, this is Mrs. Crandall, and we are talking about factoring polynomials with four terms. I actually find that this, even though the problems seem more complicated, I think that once we practice factoring, this becomes actually pretty easy. The reason why is because the four terms, like we're used to seeing four terms, we still need to check for greatest common factor, but if we don't have one that we can factor out from all the terms, then we actually go right into splitting up the problem. So you got two groups. So you've done this before. You're factoring out a greatest common factor. The greatest common factor from the first group is 5n squared. So divide 5n squared to both the terms and you get n. And divide 5n squared to the second term and you get -2. Then divide or find the greatest common factor here, which is 3n and -6. It's going to be a +3. So this sign is positive. We're factoring out a +3. Divide each term by 3 and you get n minus 2. Then matching factors. So n minus 2 at the front, 5n squared plus 3 next to it. Again, the order does not matter. Number 2, look for a greatest common factor. I'm looking at my n's. Well, that last term doesn't contain an n, so I'm not going to factor out an n. And then no numbers that I can factor out. So, excuse me. Group it. GCF. So we're dividing this term by 4n squared. We get 3n. Divide the second term by 4n squared. We get 1. Greatest common factor of the second group, it's 1. Oop, and I didn't even write it in. Forgot it. So factor out a 1, you still end up with 3n plus 1. And here we go, 3n plus 1 and 4n squared plus 1. So remember that we have a difference of squares, not a sum of squares. We can't factor that any further. It does not work. Solving by factoring, same idea, but one thing that we need to do from the very beginning, if we don't, it's going to make our life a lot harder. Notice that all of the terms contain an x. Let's factor that out. Then I'm going to put that at the bottom because I told you earlier, I forget that greatest common factor. I just completely ignore it. So next we are going to factor out an x squared from the first group, which is x minus 2, and 3x and -6. We're going to factor out a 3. We get x minus 2, all equals 0. And now we have a common factor of x minus 2. Put it down here next to my GCF. And then x squared plus 3. Okay, so now I actually have 3 factors here that I can set equal to 0. Something interesting happens in this last factor, though. So earlier, we had just a number here. I can't remember what example it was, but maybe in a previous video. But now setting x equal to 0 actually works. So that is one of our solutions. We're going to set x equal to 0. We're going to set x minus 2 equal to 0. And then we're going to set x squared plus 3 equal to 0. So this one is easy enough to solve, this middle one. We get 2. So x equals 0 is a solution. X equals 2 is a solution. And for this one, we actually, it's the best thing for us to do is to isolate x squared. So we're going to subtract 3. We get x squared equals -3. And the reason why I wanted to isolate x squared is that if you try to factor x squared plus 3, definitely not factorable. So we have to think of our other solving methods. And I immediately think of square roots because this square term is easily isolated. So I'm going to square root either side. Remember that when you square root either side, you are introducing that plus or minus symbol because you need to account for the 2 possible solutions that could be for x. So x is equal to plus or minus. Now here is where things get interesting. The square root of -3. If you think about it, there isn't a number that you can square, meaning there isn't a number that you can square that can equal -3. So you have to think back to a type of number system that was invented to account for these possible solutions. And so you might remember that I is an imaginary number, and that equals the square root of -1. So anytime that you take the square root of a negative number, there is an I in your answer. Really, the square root of -3 is the same thing as the square root of -1 times the square root of 3. I'm throwing a lot of information at you. Hopefully this is a review. So when you have the square root of -1, that turns into I, but look what we're left with, the square root of 3. That cannot be simplified. So our solutions for this polynomial is x equals 0, x equals 2, and x equals plus or minus I times the square root of 3. Okay, that's it.